All right. Welcome, everybody. We are going to start talking about indirect measurement today. And it's all about how do you measure something that you can't measure directly? Like you can't just take a ruler and, for whatever reason, measure how long it is. How can we use what we know to figure out measurements? And I'm going to have you start by being detectives a little bit here. We're going to pause and you're going to have a chance to discuss a little bit. If we were in this situation, let's say this is you. You're down here um, looking at the pyramids, and you want to measure how tall one of these pyramids is. Okay, so you want to know, like, from the tip to the ground, how, like, straight down, how tall it was. Well, you can't really do that directly, right? Because if you got a ruler to the top of the pyramid and try to drop it straight down, well, the pyramid's in your way, right? It's going through straight rock. So if you measure like down the side, that wouldn't really do it because it's at an angle, so it's going to be longer than it would be straight down. So you want to figure out how tall this is, and there is a way to do it using the math that we've been doing. So I want to see if you can figure it out. So pause the video here, see if you can figure out a way to do it using what we know. All right, welcome back. So the idea to do this is the key lies in the shadows. So if you'll notice, the pyramid is casting a shadow. You're casting a shadow. Well, you know how tall you are, and we want to know how tall the pyramids are. So what we can do is we can use properties of similar polygons to find distances or lengths that are difficult to measure directly. Okay? So if we draw out a picture, so here's a picture of the pyramid. Okay, this is the height of the pyramid. This is the length of the pyramid shadow. This is your height. This is the length of your shadow. Do you see these similar figures? Okay. Assuming this is happening at the same time of day, the sun's going to be in the same place. Okay, so the angle the sun's coming in is going to be the same, which will make these similar, and it means we can use proportions to answer this question. Okay, so we draw a picture, label the picture, write a proportion using the information in your picture, and solve. Okay, so you would write how tall you are here, how long your shadow is here. You can measure the shadow of the pyramid because that goes along the ground. So tell me how long that is. Okay, so you can fill in that. And then all we're trying to solve for is the length, the height of the pyramid. Okay, so we're going to do some examples where we're using shadows and things like that in similar shapes to solve for missing pieces. Now, I want to give you a warning right off the bat because in a lot of these pictures, it's easy to get mixed up because sometimes you got the triangles overlapping. Okay, so looking at this, you might be able to easily see the big triangle here and a small triangle here. In a lot of cases, it might be beneficial for you to kind of move them apart. Okay, when you move them apart, you can see the 21 corresponds to the X, the 12 corresponds to the 20. Okay, but that can be kind of hard to see when they're overlapping like this, especially if we did something like not telling you this whole side was 20, but like saying this was 12 and this is 8, for instance. You would have to add those together to get the whole side. So if you're getting confused by the pictures overlapping, it might be a good idea to move them apart. Okay. If you're not a big deal, but some advice. All right, so let's look at an example of some actual numbers here. So we're going to use this pyramid idea to find the height of this tree. So we know this tree casts a shadow 12 feet long. And Marcel, who's 5.5 feet tall, casts a shadow that's 3 feet long. Okay, I want to find out how tall the tree is. So we can set up a ratio. Okay? The height of the tree is going to correspond to the height of Marcel. So the height of the tree, we'll call that T, corresponds to the height of Marcel, which is 5.5. Okay, and then when I'm doing the ratio between the shadows, again, I started with the tree. So I got to do the tree's shadow on top and Marcel's shadow on bottom. Okay, so those of you who have an eye for shortcuts might notice the top here is 4 times bigger than the bottom. So that should be the same thing here. So you could just take this and multiply by 4. Okay, if you don't see that, that's fine. We can just cross multiply 3t equals 12 times 5.5 is 66. Divide both sides by 3. And you get t equals 22 feet. So the tree is 22 feet tall in this case, which is what you get if you multiply this by 4. Okay. All right, how about this one? So it says Jason casts a shadow that's 10 feet long. In these examples, I drew pictures for you. If there's not a picture, please start by drawing a picture. It's going to be very helpful. It's a good habit to get into. So Jason casts a shadow that's 10 feet long, so here's his shadow. A flagpole casts a shadow that's 40 feet long. Okay, and the flagpole is 20 feet tall. I know how tall Jason is. Okay, so again, we got the big triangle here, the small triangle here. Okay, so Jason's height, which is x, corresponds to the height of the flagpole, which is 20. Okay, then looking at the other side, we started with Jason's height, so Jason's shadow is 10 feet. The flagpole shadow is 40 feet. Okay. Again, you might notice this is twice as big as that, so this should be twice as big as that. So it's going to be 5. Okay, you can go through the motions if you don't see that. 40x equals 200. Divide by 40. You get x equals 5. Okay. All right, so here's another situation in which proportions have been used to measure things indirectly. Let's say you want to measure the distance across this river, and you can't do it directly. Well, you can do it by setting up a couple of things you can measure. So on this side of the river, you measure back 48 feet, measure over 60 feet, and then you draw a line going all the way across the river. Okay, measure where it's going to hit, and see this is 20 feet further over to hit where it's going to go across the river. Okay, so we can set up 2 proportional triangles like this, and we could use this to solve for the distance across the river. Okay, so think about what matches up with what. Okay, if you notice, I have these angles measured, they're the same. So that means kind of this point where the 2 triangles touch, those correspond. Okay. Here I have a right angle, here I have a right angle. So we would have to take this, we'd have to swing it up 180 degrees to line up with this, right? So D is going to line up with B. Okay, E is going to line up with A. Okay. So if we're going to do a proportion, we'll start with what we want to know, which is D, distance across the stream. And think about what side of the other triangle that does that correspond to. Okay, well, that's the side that's between the right angle and the one with the 2 arcs. So that's right here. So D corresponds to 48. Okay, this side would match up with this side. Okay. Well, the other thing that we know is we know these, and we can see that if we flip this over, CD also corresponds to BC. Well, that's good. So it's another pair of corresponding angles. Okay. Now, if I think about what goes on top, remember I started with D on top in my first ratio. So I got to use the same triangle. And I'll go with that 20 on top here. So 20 over 30. Okay. All right, now let's solve this. I can do 30 times D equals 20 times 48 is 960. Okay, divide both sides by 30. And I get D equals 32. Okay, so I know it's 32 meters across the river in that case. All right, why don't you try this one? So I got a similar picture labeled here. This is 28 feet, that's 20 feet, that's 5 feet. I want to know the distance across the river. So I'll pause it here. You give that a shot, and then we'll resume. All right, welcome back. Hopefully you got 7 for your answer. It's 7 feet across. Okay. Again, using these proportions, a D corresponds to 48, or 28, sorry. 5 corresponds to 20. Okay, you might notice this is 4 times bigger than this, so a fourth of this would be 7. Or you could solve it out like this. All right, let's do one more together. Find the length of Kentucky lanes. This is where it's we got to be real careful. Okay, again, I'm going to highlight in different colors here the 2 triangles so you can see them. So here's the small triangle in red. Now let's do that a little better. Highlighter. Highlight in red. Okay. So there's the small triangle. The big triangle, let's do it in green. Right here. Okay. All right, so if I am trying to find Kentucky Lane, that's this right here. Let's call that X, or let's call it K for Kentucky. So semi-proportion. K is going to, of course, the long side is going to correspond to the 6. Okay, if I look for the other pair of corresponding sides I have, I don't know this side. I do know the bottom, but we want to be real careful here. Right? So K is the big green triangle. The bottom part of this big green triangle is not 4. This is 8 miles, right? Because so this is 4 and this is 4. So you have to add those together to get 8. Okay. On the small triangle, the bottom side is 4. Okay, so you got to be real careful here. Okay. All right, so if we solve this, we can do 4K equals 6 times 8 is 48. Divide by 4. You get K equals 12. And it's in miles, so 12 miles. So Kentucky Lane is 12 miles. If you noticed that these are both 4, so the big triangle is just double, and so you double this. Thumbs up. It's good proportional reasoning. Okay, but this is how we can get there using the proportion. All right, that's all I got for you today. Give it a shot. We'll talk more about indirect measurement tomorrow.